Hello, friends. Good morning, and you're welcome to today's class. And briefly, I'll be taking you on 2024 JAMB likely questions in chemistry. Once again, you're welcome to Edward Global Chronicles, where we teach students and also we impart knowledge that will enable them write exams by themselves and become successful. So on the board now, we have a question. It said, what is the molar mass in grams per mole of a substance if 0.4 mole of the substance has a mass of 25.0 grams? Now what it entails is this: use the general formula in solving mole. We said that's the number of moles, number of moles, otherwise represented as N, that's amount, is equal to mass, that's small m, over, and mass is measured in grams, okay, over molar mass, that's big M. Molar mass, okay, is big M. So probably what it means is this: we have N is equals to, okay, already we will give it we have to look for the molarity, right? Where we have our N, number of moles, is equals to 0.4, and our mass given was 25.0 grams, okay? And molarity was not given, so we have to look for the molar mass in grams per mole, okay? So this is what we're going to do. Now, number of moles given to us, we have 0.4 is equal to mass given to us here is 25.0 grams, all over molarity is measured in what? Let's represent it as x mole, grams per mole, grams per mole, okay? Now what do? In order to get a molar mass, we have to cross multiply. When we cross multiply, I will just use this space here. We're going to have 0.4x, okay? Yes, 0.4x, okay, it's equal to 25.0. and what do? Divide both sides by s. Divide both sides, by 0.4 by 0.4, so we can have our x. So 0.4 x divided by 0.4 is equal to 25.0 divided by 0.4. To divide both sides, we have x is equal to, let me get this, is equal to x, that's 25 divided by 0.4. We're going to have 25 divided by 0.4, we're going to have 62.5, okay? So 62.5. Therefore, from the option given to us, we have 6.3, we have 4.0, we have 62.5, we have D 2.5. So the answer here is what? 62.5. Question here is, it said, what is the temperature of a given mass of a gas initially at 0 degrees Celsius and at 9 atmospheres if the pressure is reduced to 3 atmosphere at constant volume? Now what is required of you is this: to understand the question. When solving, you have to understand the question given to you. They said, what is the temperature? We're looking for temperature of a given mass of a gas initially at 0 degrees Celsius and 9 atmosphere if the pressure is reduced to 3 atmosphere at constant volume. Now what it means is this: that in the process, that volume remains the same, it doesn't change, it was just constant in the reaction. So what do? Looking at this formula, we're going to pick out our parameters. It said, what is the temperature of a given mass of a gas initially at what temperature? 0 degrees. That's at T1. So let me put down the solution. At T1, that's volume, temperature rather, is 0, but we have to convert it to Kelvin. So what do? We have 0 plus 273 will give us what? 273 okay, Kelvins. So from the question again, and 9 atmosphere, that's our P1 temperature, is equal to what? 9 atm, that's atmosphere. If the pressure is reduced to 3 atmosphere, that's P2 is equal to 3 atm, and we are looking for what? Our temperature, that's T2. So T2 was not given. Now from this question, if you look very well, the required equation to use here is called what? An ideal gas equation. We have the general gas equation, but this is what is required is what? Ideal gas equation, whereby we can just make this as P1 over T1 is equal to what? P2 over T2, knowing that PV is equal to what? nRT. Okay, where RO stands as a what? Ideal gas constant, what? Constant. So we have our P1 over T1 is equal to P2 over T2. So our P1 is given as 9 over T1 is 273 is equal to P2. What's our P2 here? P2 here is 3, and our T2 is not given. So what do? We cross multiply, and we have 9T2 is equal to 273 times 3. 273 times 3. So we have 9T2 is equal to 273 times 3 is equal to 819. So we divide both sides by 9 to get our T2. So we have T2 is equal to 819 over 9. Our T2 is equal to 819 divided by 9 will give us 91 kelvins. And okay, although the option is there, so the answer is what? 91 kelvins. Okay, this is our answer.